Yo, yo, yo. What's up, everybody? What's up over on YouTube? Gonna have a hard time pronouncing that name. Once upon a time I could, but not anymore. Okay. So yesterday, Unity started to crash a lot. I think the reason is that we send a big workload to the GPU. It takes too long. I don't know if it's Windows that resets the GPU and Unity crashes, something like that. And this is a pretty common problem, unfortunately. I guess it's one of those problems where the cause for it can be a multitude of different things. So also a problem that is extremely hard to debug. But let's see here. I have done a lot of things to hopefully reduce the number of crashes or hopefully remove them altogether today. We have new drivers. We have less load on the GPU from other software as opposed to Unity, and some other minor things. So I don't know, we can watch the scene and we can run around today at least, and that's a start. So let's just hope it works, and let's try and do some real work today. Although I haven't tried... Fuck, now it's probably gonna crash. But if we do this... Okay, beautiful. And if we do this, okay, we will probably be able to do some work today at least. Okay, great. So what we're seeing here is what we're gonna work with today. Pretty much we're seeing a plane. I think the initial plane is 8x8 quads or something like that. We send it down to the GPU where we render it using a shader that has some that also has tessellation shaders or tessellation passes, and we tessellate this mesh based on the distance from each quad to the camera, basically. So you see quads extremely close to the camera, tessellated a lot. Quads far away from the camera, not tessellated at all. And we can adjust the maximum amount of tessellation we do, and we can adjust the maximum distance. So smaller distance here, we stop tessellating closer, pretty much. We can do this. And I'm extremely optimistic about the fact that we can render this without no problems. That's good. Okay, and what we're doing here, let me deselect it, or actually we can do remove the selection wire. We have this white and black pattern per quad. Basically what it is if a vertex has a color of black, it means, or the black and white color represents the age of a vertex. So if we move closer here, age is not the correct term, or not the term I want to use. Do we have anything else? Age works for now. It's basically like, given how close we are to the camera currently, how long was it since we spawned this vertex. So it's basically, if it's black, we just spawn this vertex. If it's pure white, this vertex has been around for a long time. And we have normalized it as a value between 0 and 1. It's because, like, when we move away from this plane under us, so right about here, we tessellate, so we get a lot of new vertices. We don't want to displace these vertices directly, because if we do that, we will get popping. Very visible popping. Yo, what's up, Geralt? And like, it will just look like shit. When the character is running through a landscape, you will see this popping as the environment gets more and more detailed. Instead, we want to add these new vertices, but at this point, we don't want to displace them at all. And then the closer we get, the more we displace them. So here they are like fully displaced as they should be. And yes, initially I thought that getting this data, which we have rendered now, would be the hard part. I think the hardest part was to sync it between quads like this. But the hardest part is probably going to be, so let's see here, at this point, we spawn a hell of a lot, a big amount of new vertices. And actually we can do this. Let's zoom in a bit. Let's minimize this amount so it's easier to point at specific vertices. But okay, look at this quad here, for instance. As we get closer to this one, this quad is gonna consist of 5 more vertices. We're gonna get a vertex here, 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 and here, and one here. I think that's correct. We can double check it. Here, 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 and here, yes. And these new vertices are all colored with black. So they have a age value of 0, because that's basically what we're rendering here. We're rendering the age value. So when we spawn this vertex, instead of reading the height map and the displacement map directly from this UV and then recreating the height of it, we actually want this one to be the interpolation of this one and this one. So for this one, we want to create one vertex that is displaced how this one should be displaced. So how we originally did it. But then we want to create one position that is the interpolation of this one and this one at 0.5. So right in the middle of this edge here. And then depending on the age value, we want to lerp between those two positions. Pretty damn straightforward. No problems there, I don't think. The problem is if we look at some of the other vertices, or the problem is going to be apparent when we start looking at some of the other vertices. So if we look at this one that spawned as well, for this one, we don't want to interpolate between this point and this point, because this point gets spawned between these two. So it's this one and this one. So in some way in the shader here, we are gonna need to use the edge data, or like in some way try and get, like, we need to calculate which vertices the position of this one should depend on. So for this vertex, it's this and this. For this one, it's this and this. For this one, it's this and this. For this one, it's this and this. And for this one, it's this and this. And to make things even worse, so for this point, we go, what is it? Left up and down right. But here, for the vertex that spawns in the middle here, we're gonna go up right and bottom left. So there are a big amount of different permutations. Is that the correct pronunciation? So yeah, this is probably what we're gonna spend the rest of the day on. Calvino, good morning, good morning. Did you resolve yesterday's issue? I've done my best to resolve it. It's one of those issues that can have many causes. I've taken some steps to try and minimize it. I've tried to minimize the load I put on the GPU while streaming, and I've installed some new drivers and versions for other software. And so far we haven't got a crash, but I'm pretty much sitting on nails here. I wouldn't be surprised if we get a crash or two today, but at least we can do some work here. And yeah, so we're just gonna hope for the best. Pretty much. So if we take a look at this task here, it's pretty much tessellate. Yeah, it's pretty much an improvement of tessellation we're going to focus on today, and I think this task is going to be quite hard. I'm going to, hopefully by the end of it, we have gathered some new knowledge about tessellation, because if we look at it, what I would want, like, we need more information about the topology, basically. I don't know. We could probably get that information from the calculations we have done so far. So pretty much how we tessellate a quad, we can derive the information from that. And honestly, I don't really know where to even begin at this point. We did do some... Actually, what we did last Friday at the end of the stream was to create a... We created a quad, sort of a test quad. We added some height map and some activity data to it. I think that's a good start. So we're going to go back to that test quad. I think I should still have it in the scene, and we can experiment with it. So now I'm quitting this. Let's see if it crashed when we restart it. So if we jump to the shader in question, what is it? Procedural snow. And we jump down to about position center interpolated. So here we did some... I'm actually going to open up GIMP as well. We're going to do some drawings here. Hopefully I can make a little bit of a higher quality drawing than I usually do. Something we can reuse multiple times. So I want to do... If we take the original quad, like this, And then we can do 20 maybe. 40. Something like that. I'm just gonna bring up the old sketch here. I think I have it on my mobile phone. And we had there, yes. Because when we go to the tessellation shader, the order of the vertices and edges are a little bit unintuitive. So we can start by doing, okay, 32. Okay, that's good enough, I think. So this is actually edge 0. This one right here is edge, we get edge, what did I say? Edge 3. Edge 1. And no, one sec. This is edge 1. And this is edge 2. And then let's do vertex 0, vertex 1, vertex 2, and vertex 3. And if we have the world x-axis in this direction, and we have world z direction in this, and then we have y straight up, basically. This is our world, and then for our UVs, we actually have, so when we create these vertices per quad, let's see that this is our whole mesh, but then we basically have x in this direction, and then we have y in this direction. Something we noticed, however, is that the tessellation is the opposite. So when I say tessellation, I'm talking about the UV we get as an argument here, so the domain location. The domain location actually turned out to be opposite to this one. So domain location I'm gonna put inside, which screwed with me a bit. So like all of this is still very experimental. I might be wrong on some parts. That's pretty much. And we figured this out when we were trying to calculate the age of vertices. And then I also want to do this because we have something in here as well. These two. This one is inside 0. And this one is inside 1. This is pretty much the information we have gathered so far. So i.e., when we want to, if we take the original quad, when we want to subdivide it, once like this, then we do E1 is equal to 2, E2 is equal to 2, E3 2, E0 2, I0 2, I1 2. So number of edges, if I remember correctly. So what we did down here, so in our calculate snow vertex, we calculate the proper position a vertex should have. Like we read some data in textures, we read height data and activity data, and then we calculate the proper vertex position based on that data. Out here at the end, we calculate something I called position center interpolated. And this is the position relative to its neighbor that it should have if it's newly created. So this right here is, so if we would add a new vertex, let's go here. If we would add a new vertex right here, position center interpolated is the position this one has on this edge right here, if we interpolate the V3 and V2. Right. And we can see here that we did some direction calculations. So this was the first try of, or the first test of trying to get the direction, like figuring out which vertices should we interpolate the position from. And here we did, or I did, the first mistake. So we pretty much did these calculations under the assumption that all quads will have a diagonal split from top left to bottom right, because if so, we can calculate the UV here. So if this one has a UV of 0, this one has a UV of 0, 1, that means that this one, I'm talking about this UV now, this one has a UV of, or actually this one has a UV of, what is it? 0, 1, no, 1, 0, and this one has a UV of 1, 1. That means that this one has a UV of 1, 0.5. And by that information, we know that this one is not a new vertex on the x direction, because it has a the precision for which we say the x coordinate is 0.5, or is 1 or 0, while the precision for the y coordinate is 0.5. So the precision is more precise for the y coordinate than the x coordinate, i.e. the y coordinate is the new one, so to speak. For this one, however, we have, well, let's not talk about this one right now. Or we could go with this one. For this one has a UV of 0.5, 0.5, while, and that's the new precision, so we know that both x and y are new here. But then the question is, should we interpolate from V1, V2, V0, V3, or yeah, should we like interpolate between these two or these two? That we don't know. For our current solution, we did assume that all went from top left to bottom right, so we always interpolated between V1 and V2 in that case. Unfortunately, this tessellated mesh we're working with we have some more logic to take into account. But with that said, with this logic we're using now, that means that every vertex that is new in only one direction, so this one for instance, or this one, for those we should be able to easily calculate which vertices to interpolate from. And I think I'm going to start today with trying to get those right. And when we have those fixed, we can hopefully get these in order as well. Okay, so that's the problem from beginning to finish. So what I want to do first is I want to take my environment, character, stool, and bed, and we're going to disable those, and instead we are gonna enable test quad right here. If we take a look, is it test quad though? If we take a look at this script, test quad, let's see what we have. We add a mesh filter, we add a mesh renderer, and then we create a mesh that is positioned at, that has a size of 10 times 10. So in Unity units, so I think that's meters. So 10 times 10 meters. It's subdivided, or it has a resolution of 4, which means that we have 16 vertices, 3 times 3 edges. And we also have a material here which we add to the mesh renderer. Right now, this is the procedural snow terrain material. And then we have terrain active data here, which we put to this texture. So pretty much we want to displace this quad we create using this texture. And this is it's not the best texture, but this one is, the values are either black or white. We get good displacement from it. Yo, what's up, Cooler SK? So let's see if we can start this scene with this test quad without crashes. That's the first step. So let's play this shit. Can we watch it in the scene? Yes, we can. We can select it. And we can see here that we get some displacement. But we can also see here that, so this is probably the best way to visualize it. So if I go one step closer to this one right here, we're going to get a new vertex here, and we can see that that vertex displaces to its eventual position instantly. So like this is the position we eventually want it at, but it jumps to it instantly. Instead, when we move to here, we would like this one to be a little bit lower down, right? Because we want it to be based on this and this. But let's try what happens if we increase this to about here, I reckon. I wonder if we would also like to make it easier to test with this, I think we would like to take displace test and put it at point filter. Is it going to crash now while we do it? I thought that would give us, could it be, let me open this one up in GIMP, let's take a look at how it actually looks. what is it called? Displays test. And it's under environment. Displays test, open with. We don't have any fading here. I wonder about this position and this position. If we're doing point sampling, but we might need to restart it. What's up, Page of Moths? Height maps indeed. Coolers K, mostly I'm up to being sick. That sucks. Get well soon. Hopefully nothing too serious. I wonder about these. Let's restart this. Maybe the terrain system uses its own texture sampling and doesn't honor the texture sampling mode. That is 100% true. So this is our custom terrain system. And right now we're actually reading a height map, but you are 100% spot on. Because if we take a look at the shader in question, and we take a look at, bam, there we have it. Get terrain active data level bilinear. So let's try and see what happens if we get terrain based data level bilinear. Let's do bilinear. And I think we can just remove these. Interpolate bilinear, we still want to do that. Interpolate bilinear, we still want to do that. We have a lot of bilinear. This one we want to remove. Bilinear, blah, 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 blah. Okay, I think that should be it. There we go. Fucking spot on, Moths. Good catch. Okay, so what do we have to work with now? Now we have more of a fade I initially thought we would have. Or no fade at all, basically. Okay, so now we can focus on the problem. This vertex, we can start with this one. I think it's the easiest to fix. When it's purely white, then we want it to be in this position. If we step back and it's a little bit more gray, we want to interpolate it here. We want to bring it down a bit, bring it down, and bring it down. And so right about here, we would like the new vertex to spawn here. So this is going to be our interpolated position. This is going to be our end position. So then we interpolate between those two. So here it starts at the start position and then closer to end position, closer to end position, closer to end position, at end position. And then we interpolate more, and we want to do the same for these. I hope all of this makes sense. But yeah, so this is pretty damn straightforward. So at this, the age we see here, as I mentioned, it's based on the UVs. So let's assume that this one has a UV of 0.25. Let's see here. Yeah. Let's say that this one has a UV of 0.250 and this one has of 0.50. That's not the case, but as an example, that means that this vertex has a UV of 0.1250. So in the y direction, they have the same. This one has more precision. So we know that it moves in the x direction, and that's how we calculate the direction here. And right now I just set it to 1, 0, but that's how we did it previously. Here we have it. So UVX modulus x compare value is not equal to 0. It's not equal to 0. So we get either a 0 or 1 here. If it's 1, we want to interpolate it in that direction. If it's 0, we don't. So for this one, we would be getting a direction of 1, 0. And we would be calculating our neighbor snow vertex from like this. So it would be 2, 1, 0, 1. So only moving in the x direction, and that's this one. So we're going to start by removing this one. Shub, I just started watching you and was disappointed the last upload was 1 year ago. Happy you're back. Appreciate it. So yeah, my last devlog was quite a while back, more than a year, I think. But I tend to stream every weekday, at least for around 4 hours. You can I think all the VODs are available on YouTube. And recently I also began doing some shorts once a week. And I've also started doing my next devlog. So hopefully we can get some high quality devlogs released this year. Okay, so let's see what our direction actually does. So now we use the proper direction. Let's see what that leaves us with. I don't see any change here. So let's take a look. Position center interpolated. If this place is, yeah. So then we have the lerp variable here now. For now, this one is just set to 1, which means that we're always going to return this one. And this is the end position. So start position, end position. And then we want to lerp between these two based on the age. And the age variable we have in, I think we put it in output test. So it's actually max progress. So what happens if we set max progress here? Maybe not the best name, but yeah, then we get something like this. And this was pretty much where I had to run. Last Friday. And we can see here that the end position, we can see here that the end position is actually correct, but the start position is wrong. So in this case, we end up at the correct point, but the start position is sorta fucked. We get a start position that is upwards here, and we get a start position here that is downwards. So something is... let's take a look. So for this vertex we spawn here, we actually spawn it at the new position. But for these we don't. Okay. So for the new... yeah, for the new vertices in the X direction, we just spawn them at the end position. The problem is the Y position here. Very interested about this one, whatever is going on here as well. Okay, so let's take a look at... I want to bring back... direction here. I'm just gonna set it to 1 1 0. So we should only interpolate in the X direction. What do we get then? Here we get 2, here we get 0. And then we take the middle point of those two. Yeah, this one's still extremely wrong. Why do we get a 0? All new vertices has a height value of 0. Yo, what's up there, Rick? Sorry I'm late. Nothing to be sorry about. I'm just happy that people come around and watch. Yeah, the original position is fucked. So what we should be getting here is this one and this one. Let me bring this one up a bit as well. Oh, not that one. This one. So the new vertices here get a height of 0, but here they have... We're doing this... Okay, the biggest problem is that this one at least should be able to make this one work. So it should spawn right around here, I reckon, when it has a black value, because we're interpolating between this one and this one, or that's what we want to do. But that's not what's happening. I wonder if we're interpolating between... Are we interpolating between... We do 0, 1. Really? Still have this going on here. Basically, right now, I'm just trying to identify... I'm just trying to identify the error, like, where does it go wrong? Or identify a way we can change this implementation such that we can circle down exactly what is going wrong. Why is this one getting its origin? It's 100% the direction. Could it be... Could it be that we want to do... So here we have the perfect example of what I meant with the UVs we assign to the vertices and the UVs during tessellation being flipped. Here we check the tessellation in the... or here, I mean. So Y for the tessellation is here, is horizontal, and X in the tessellation direction is vertical. So I'm wondering if that's what we want to do here as well. Get the direction, which gives us this. Oh, is this one actually moving up? Should be. Like, what is this? Could it be, are we reading... When we set the original positions, are we reading too big of a... Oh, could that be it? Base data, UV. I want to do... Here we have UV step. We do X compare value, Y compare value, yes. So we actually move one step too much, I think. Let's see if I can do some drawing here to What color? Okay. So if we only have the original quad, we don't have this. And yes, we have this. 4 vertices, 4 edges. Don't mind the inside edges. What I think is happening is that, so basically we're calculating one step in UV between neighboring vertices. That's our X compare and Y compare value. Bad naming. We'll get to that eventually. So in this case, when we tessellate this once, we get a compare value of, so let's say that we're going from, let's put this one at 0, 1. We're using this UV now. Let's use this one. So let's put this one at 1, 0. So this is the UV for this one. And this one has a UV of 1, 1. That leaves our compare value. Unfortunately, we just take the max here. We probably want to keep it around for this UV step. But our compare value here is 1, because that's the step size here. So if we have compare value X and Y, we actually have 1, 1. So one step in X is 1, one step in Y is 1. So if we tessellate this one in such a way that we get a new point here, this one's UV is 1, 0.5. So when we analyze this UV, we can check here that this one has actually a step size of compare value. So this one doesn't change. This one is 1 less, or 1 more precision when it gets to the step value, because like these are always going to be 1, 0.5, 0.25, 0.125, and on and on and on. So we can check here. This vertex is new on the Y direction, so horizontal. But what I do then, when we calculate our neighbors, we do it by max progress, or the big compare value, so this one. So when we get the neighbors for this one, we actually get the value for whatever this one has, and the value for whatever this one has. And that explains these, although it's a little bit too. This one I understand, because this one gets a neighbor right about here, maybe. But still, this is at least one error we're making. Instead, when we do the UV step here, so when we get neighboring vertices, we actually want to base these UV step on X compare value minus 1, I reckon. But that is gonna screw up some other stuff we're doing. Or is it? I'm thinking about the fact when we have when we calculate the normals, it might get what if we do, I just want to see what happens if we do divided by 2 divided by absolutely not, but 2. So our UV step is always 1 precision higher. But we could also base it on this. Let's see what we get. Look at this. Look at this one. Look at this one. It actually spawns in the correct one. And then it goes up, not quick enough. What if we do, we can do, look at this one. This one actually spawns at the correct position, but yeah, this one is perfect. But we have this one and this one still a problem. And then we get closer and it fades to its correct position. Wow, wow, wow. Huh. Okay, so what the hell happens with this one is my question then. And these. So look at this. Yeah, I don't know how visible it is when we actually print the age of the vertices, but if everything would have been white here, and we put this as far away from the camera, you wouldn't get popping here, you would get some beautiful fading. That's beautiful. But what the hell happens here is my question. Yeah, I think we're going... It's weird that we're going one step too far on this one, but not on this one. So this one should interpolate from this and this, but it seems to be interpolating from this and this, right? Same with this one. This one seems to be interpolating between... This one interpolates between this one and this one, I reckon. I don't mind that much that we still don't have this under control. I'm just happy that we don't crash anymore. Yeah, we still have the same issue here. Okay, this is weird. So by doing this, we fix some of the vertices, but not all of them. And I wonder, let me take a sec. X compare value, Y compare value. I'm just brute forcing stuff right now, but we know that they are flipped. UV step, however, is not flipped. What do we get by flipped like this? Still the correct here. Same problem, basically. Stat. Yeah, I wonder if we want to do UV step. I think we want to do the max of these. I want to try it. Huh. Here we still have a problem, but this one, look at this one right now. Beautiful. Look at these. Beautiful. Okay, so now it's starting to look like something. Look at it. This one, still fucked. Get this one working. Oh, look at this. Look at this. Oh my god. Oh. This one's still going up, this one not. What's up with that? Oh. If and when we get this in order, I think it's gonna look beautiful. Then we just have to put it far enough from the camera so it's not that visible. These, however, what the fuck? We don't even have any seam problems, so I'm talking about if we take a look at the original quads, we don't have any difference between them, not that I can see. Even though we get like wrong offsets, that's beautiful. But okay, this one. What's up with this one? And why don't we get it here? Okay. This seems to definitely be reading this one. And 1, 2, 3. Well, let's see here. 1, 2, 3. 1, 2, 3. So it's probably reading this one and this one. Why? Look at this. Hmm. This is also very strange. Look at what is it? Yeah, the vertex we spawn here and here. At this point, they are synced. They get the same kind of error. But when we spawn a vertex here and here, this one works. This one does not. Terrain activity data. It's not centered, but still. Jesus. Oh, it works so good in most cases, but here, no. Oh, I wonder. I find it weird that the vertex at the end is wrong as well. I would have understood it better if this one and this one, if these were wrong but this one were correct, because we can't handle the diagonal. If we check the diagonal here, it goes like this, while it goes in this direction here. Yeah, what's up, Bruce? Is this Nanite version 2? Nanite version 0.1.2 maybe. This one is weird. We have Nanite at home. Yeah, definitely. Good enough, ship it. Fuck, I'm trying to find a pattern for why this one... Why won't you behave? Why won't this line of vertices behave? I think it's pretty apparent that these, they get a UV step that is greater than it should be. But I don't see how that would be possible. So it's either this... It has to be... It's either this one or this one that's wrong. Do we want to do... Let's see here, I need to think. Direction. Let's put this one down here. I'm wondering... This is how we want to do it. Or one sec, if we do it like this... So the UVs that doesn't... Where modulus diff doesn't return, results in 0. That's true for the vertices. That we should have this UV step. No. And now we're back at popping again. Yes, because we want to do this one, don't we? Or... Huh. Okay, diff is the vertices that are old. So vertices that has a UV value that we can do modulus on, not getting any rest. Bruce, so it's like you have a matrix 2 times 2 and you add 5 more points to make it 3 times 3 and so on relative to current distance to the camera. Yes, pretty much. With some special cases to make the seams work and stuff like that. So once again, like if we have an original quad with 4 vertices and we want to add a vertex here, relative to camera distance, we want to offset it either base, like depending on the distance to camera, either base, we want to set this position as a interpolation between this one and this one, or we want to calculate its individual value basically. So that's what you see here for the ones that works. So here we add a vertex. When we just add it, we just interpolate its position based on this point and this point. But when we get closer, we move it towards its final position. It's to reduce popping. The only problem here is that we get some vertices that they don't calculate their interpolated value in the correct way. So for most of these, it works. But then we have some fucked up ones. And that's what I'm trying to get to the bottom of. Hardest part, which actually works kind of good right now, is what you see here. So that's the seam between 2 original vertices. They seem to sync up pretty good. Yes. Take a look at this. We have this problem here as well. These should be interpolated between this one and this one, so we should not be seeing whatever we're seeing here. I have no idea why these won't adhere to the rule set. I'm pretty sure it's because of this one. One sec. That won't work. So pretty much we calculate max, yeah. We calculate I'm pretty sure we want to use diff here, so that is pretty much just the max. Oh, maybe. Diff. Okay. Maybe we want to use... Oh. Let's see here. We want to use... So this is the biggest step size we have in either direction, I think. Diff. What a bad name. We want to do... Bruce, should it be smooth like a hill instead of steep? Maybe a Bezier curve can help. Yeah, we're gonna look into that later on. But basically, we're reading texture data. So the underlying data is pixels. And you are actually onto something. If we do tessellation... So usually when you tessellate meshes, where you only have the, like you base the tessellation only on the original mesh data. So let's say that we do tessellation on a sphere or a circle, but the original mesh is not very high resolution, so we have this one. Then when you generate these points, you can usually do something with Bezier curves, right? Never done it, but I have seen it and read about it, to better smooth out these points. So the newly generated vertex here, you might put up a tiny bit. So you get something like this. I've always just skimmed through it because I couldn't instantly see if it would be applicable to the exact thing we are doing right here, but maybe it could. I'm gonna do some research on that eventually. The bottom line is we should, like with the data we have and how we do it right now, we should be able to fix it. Eventually we could maybe improve. So when the tessellation resolution goes beyond the resolution of the underlying texture, at that point Bezier curves would most likely help us, according to my current understanding. Because then we start to work with data that doesn't exist in the underlying height maps and activity maps. But we'll see. I'm gonna see if I can find some time later today off stream to research the tessellation with Bezier curves. But we're definitely, let me put it this way. Edit. Fix tessellation popping and research introducing Bezier calculations for smoother tessellation. Let's put it like this for now. I think it should even have two curves, one for X and one for Y direction. Yeah, that's probably... I wonder if you even have... I think you do... Now I'm talking about something I have no idea about. So don't take this as the correct information. But I think you do Bezier curves. Are they related to the edges? Okay, okay, thin ice, but I wonder if, like, you do one Bezier curve for each edge, so you pretty much get a Bezier patch. But yeah, hopefully I can return later this week with some more knowledge about it. Or maybe even research it on stream. But let's see here. So the y and x compare value here. We don't want to do y compare value, x compare value. We want to do the max of these, I think. So we don't want to do the max of this, but we want to do float max compare value is equal to max. I want to do the max without doing the modulus first. So it's going to be x compare value, y compare value. And then we do max compare value for both of these. This problem still persists, but because when we look at this, I wonder how the introduction of Bezier curves for smoother surface would fix this. Because when we add a new point right here, we want it to be added exactly at this line. So right here. So just a linear interpolation between this one and this one. We want this one to still be linear. All right. But this one, like, we are 100% reading the wrong neighbors for this one. The question is it because we step too much, step too little? I don't know. And check. Let me do... Let's set... output.test. Output.test is equal to get terrain base data level UV center 0 dot height. That's not what I want to see. If it's bigger than 0.5 input test. What's happening here? What I would like to see, or what I thought we would see, is just the never mind. Get terrain activity data level. And we don't want height here, we want height boundary .x. So we can see here that it's black. It should be not offset at all if we read the correct data. But then again, this, yeah, we move back, but this one is interpolated between, it should be interpolated between this point and this point. But I think it's pretty clear that it's not currently. Oh, this is gonna look so good. Eventually. UV step diff. Oh. Okay, UV step. I think we might be. Yeah, I fucked up. We want to do. Or did I? UV X compare value max. Yes, we're getting 0 here when we shouldn't be getting 0. Oh, I fucked up. Let's do. What I want here is. Isn't it this one we want? Max compare value. Max compare value divided by 2. Like x compare value, y compare value are the step sizes in the x and y direction, but they are the step sizes that for the step size for the old vertices. So if we have new vertices at 0.25, max compare value is 0.5. And then we divide it once more to get the newly instantiated vertices. This makes sense, doesn't it? Oh, one sec. Ooh. We have to differentiate between UV values here as well. I think we might be having... We pretty much have 2 different UV values to take into account. I'm pretty sure. Hear me out. So if we generate this mesh initially, so this mesh we generate on the CPU. This mesh consists of 4 quads. When we generate this one, so I mean, it's not only the direction of the UVs, the 2 different UVs that are different, but it's actually the precision of them as well. So if we generate these UVs, we generate this full mesh with UVs of 0, 0, 0, 1, 1, 1, and 1, 0. But then when we do tessellation, we do it based on each quad in of itself. And the UV, this UV we get sent in here is domain location. First of all, it's split, but I'm also wondering if it's constrained to the quad it's tessellating, which means that we get, for this quad here then, we would be getting, can I make this a bit smaller? Let's take this quad. For this quad we would actually be getting 0, 0, and then it's, so we get 1, 0, we get 1, 1, and here we get 0, 1. So the step lengths are actually related to the tessellated quad in question. But I've been working with it as if this one, so the values we're working with is, for this one it's 0.5, 0. But when we do UV step, we do it for the full patch. And 0.5 is this one right here. So we need to convert this one. When we want to do the UV step in the textures, we need to convert this one from tessellated quad space to full space. So it's, we're working with SV domain location UV and patch UV. Okay, so UV step here we calculate based on this one, and I'm not sure. that's not what we want to do. With what we currently have, can we transform these step lengths? Then again, yes, we can. We have, come on, see, UV step. Here we go. 389. So we have float UV original step, and then we have the actual UV step. So if we calculate what is the relation between these two? The relationship. I don't want to send down information. I don't want to pass more information from the CPU. I want to solve this with the information we have, if possible. What I'm saying is, if we would be sending down more information from the CPU, we could easily say, tell it how many times it's subdivided, and then we just... So for here, our full patch is represented by 4 quads, so then we know that we need to half this UV. Eonf math, yes indeed. Yes indeed. How can we do it? We can do it by I think, but then again, maybe it is better to send this information down from the CPU instead of calculating for it for every vertex. But we have I mean, we could send in here we know here we know the min and max UVs for each patch. Patch. So we can do patch 1 uv.x minus patch 0 uv.x. That's our step in x. Is it? We can use this information to calculate the ratio. So it's basically going, so by going 0 to 1 in the x direction with this UV, we actually only go between 0 and 0.5 here. So that means that this one has half the resolution of this one, and then we can subdivide this one some more. But let's see here. Util math. Interpolate bilinear. We get the x here, we get the x here. One, two, three, four. So we get the x here, get the x here. We could do it in a pretty rough way, just see if this works. We could just do min max for all of these. Then we have minimum x and maximum x, and we have minimum y and maximum y. Then we take maximum x minus minimum x, maximum y minus minimum x, minimum y. And then we have the ratio. And then we do pretty fucking sure that would work. Let's do a rough implementation of it and see what we have. So it's eventually UV step we want to calculate. So let's do it like util math max go to max, go to min, oops. max. And then we do float to UV ratio is equal to float. Can we just do max minus min? So in this case, that would leave us with 0.5, 0.5. So then we know that one step for patch here is 1, 1. Then we can calculate the ratio by doing this divided by this one. We always know that this is 1, 1. So we can just do 1 divided by these values, 0.5. 1 divided by 0.5. So we get 2, 2, right? So that means that a step of 0.5 here is actually a step of I want to say that we want to divide by this one as well. Step of 0.5 is actually a step of 0.25. See, we have a UV of 0.50 here, but for the full patch, that is half that step. So we should just be able to multiply with this, which means that I want to do UV ratio times x times this one. Put it like this and this. UV ratio dot y fix the one. So something like this. And that's our final UV step. Skeptical, but min. Oh yeah. Ooh. That's it. That is it. So what if we do return 1? Is it too bright? do... Yeah. We see the popping we see here is because of the... We choose to recolor it. I'm a little bit worried about this one. Do we have... I think it's okay. I think it's a win. The popping is still... When we do it based on color, let's do 0.5. Pretty sure we have it. Would like to try it with some proper shading as well. I wonder what we have here. Oh, it looks good. We do... Yes, we have some issues left. I'm gonna show them. So we can see this one here. It still pops, right? This one, yes, because we interpolate between the wrong directions. So now we can move on to... Okay, now we have solved the easy problem. Now it's time for the hard problem, I think. Yeah, 100%. Okay, I just want to watch this a tiny bit more because this looks good. Okay. So the hard problem. Right now, when we calculate direction here, I'm pretty sure we do it for... so in the X direction and the Y direction, we do it the correct way. Let's see if we can get... Yes. So for the X and Y direction, we do it in the correct way. So we can see that it works here. The next problem is these points. The points that gets generated in the middle of a quad. Should be divided beforehand, and height should go smooth relative to distance. I think I understand you, and if so, that's pretty much what we're doing right now. So if we look at this point, when we subdivide it, when we add it, we don't change the height of it. But then as we get closer, it falls into the correct height. So it's subdivided beforehand, and then height is smoothed based on distance. And only for new vertices as well. This one, we don't do it for. This is fucking pog indeed. Like, I love this. Now I have a scroll wheel that scrolls in increments, so it's not that smooth of a scroll. But if we were running and the camera were slowly fading closer, you get way better. I get you, Bruce. Like, it's hard to see because the coloring, the white and black coloring, that one still pops, right? But that's just our underlying data I've chosen to render. So this data still pops, but the vertices, they don't use this data for displacement, so they are smooth. But as I said, this was the easy problem. Now comes the hard problem. But hopefully by solving this hard problem, we can gather some information that can help us when we eventually are going to implement quad flipping. Because when you have a mesh that has a slope, for a smoother result, you want this triangulation to be based on the smooth. Or, yeah, you want the triangulation to be based on the slope. So you always want to slope with the triangulation. Otherwise, you're going to get... see if I can... yeah, otherwise you're going to get things like this. If we would flip this quad, the triangulation of this quad, we would get a way smoother result. We're not going to do quad flipping just yet, but hopefully we're going to minimize this problem. So what I'm talking about is when we... can I get a better... yes, so here it's extremely apparent. For this quad, so for... it's hard to see what make... yeah, for this quad, when we subdivide this one, we're going to get one vertex in the middle of it. On this side, we actually base the interpolation of this vertex and this vertex, and that's correct. That is this line here. So here we get a good result. But on this side, this quad, we're going to add a vertex here, and then we're going to interpolate the height of it based on this one and this one, which gives us this one, and that's wrong, right? So what we want to do now is we want a way to figure out, so when we add a vertex here, which are the connected vertices? For this one, it's this and this. For this one, it's this and this. And I don't know. I don't know where to even begin here. I'm looping through all the available information we have at this point and trying to figure out if we can derive this from that information. And I think we can't. Because look here, if we would have gotten these 2 points, it would be beautiful. So it all comes down to a question of here. Should we do snow vertex 0, 0, 2, 1, 1? Or should we be doing 0, 1, 2, 1? This is not entirely true. Should we go 0, 0 to 2, 2? Or should we go 0, 2 to 2, 0, isn't it? Bottom left to top right, or left top to right bottom. Bruce, is it worth having mid-height calculated between 4 or 6 or 9 points? Or that's too much work? So, am I understanding you correct? So when we calculate this point, instead of calculating the height of it based on 2 points, we do it of 4 points. The problem is that see, do we have this example? Trying to find the problem with that could be we don't have this specific example with this texture, or at least I don't find it. But when we don't have such a basic height map, we could find ourselves in a case where we have this one at a height of 1, height 1, height 1, height 0, but the vertex in the middle that we generate will only be connected to this one and this one. And if we then choose to use all 4 neighbors to calculate the height, this one would still weigh in and put this middle one at a lower position than it should be. Does this make sense? So it's connected to these 2. So the center point of the connection is actually at a height of 1. But if we use all 4 neighbors, be unconnected as well, this one weighs us down. So this point would result in a lower position than we want, because when we actually put this one in, we want it to be at a height of 1. But if you if we would be using, so this newly created vertex, it actually has 8 neighbors. It has the 4 original and the 4 newly added. But yeah, we would still be getting weighted down here. So what I'm trying to explain is a case where we have we generate a point in the middle of 4 points, but we don't want to take into account the point that is lowered down. So yeah, we would be getting 1, 2, 3, 0 divided by 4. That would leave us as 0.75, right? And its real position would be 1, so we would be getting a little bit of a popping, unless we always base the final height on all its neighbors, which would lead us to, we would be getting a more smoothed result, but not as precise. So that's pretty much what we have to decide. I'm trying to think about a case. Like, the thing is that for each vertex, we always read the neighbor vertices, all 8 of them. And we do that because I want to calculate the normals. I want to get as good normals as possible. But if we base the displacement on all the neighbors, so let's say we have a point. When we calculate the height of this one, or the displacement of this one, then we take the average of all of these 9 height values. But then when we want to calculate the normals later on, then we need the heights of these as well. But if we calculate the heights of these by taking the neighbors, then we need to do this for this one as well. So instead of a 3 times 3 kernel, we're going to have to rely on a 5 times 5 kernel to get the proper normals. And that leaves us with, then I think it's too performance heavy. But like, if we would base the height on the specific, and also remember, we have 2 different maps here. We have the activity texture and the height map. But if we would base the perfect position, so that's the eventual position, on not the neighboring positions, we just read the value, whatever we have in the texture. But we do the interpolation based on neighboring values, then we would be getting popping. Yeah, 0.75. That's only a popping of 0.25 up to 1, but it's still too visible, I think. What we want to see on this side is popping like this. So here we would be getting 0.5. One sec. Yeah, we're doing... Yeah, what we want to do is interpolate between this point and this point, but we interpolate between this one and this. So what can we do to properly calculate the direction? We only have 2 different options, right? We have this one and this one. 0, 1, 2, 3. Can we change? Do we have any? If we don't, we tessellate using quads at all times. Do we have any control over quads? I guess we could probably, yeah, we do. I think we can flip them. But maybe, I wonder if we can flip them here. I don't know. It would definitely be easier if we fix the quad flipping. If we fix the quad flipping first, we have a bit more control over this. Let's see, do we have anything on this? Unity, flip quads during tessellation. How to avoid triangles. Cannot change quad split direction. I don't know about this. Yeah, this would definitely suck. But I'm pretty sure we could manage. I don't trust this 100% just yet, but we'll see. I mean, we could. I don't even know if he's doing tessellation, but if we wanted to, we could do the geometry generation ourselves. So we just do the tessellation to get the points, and then we do the actual geometry generation ourselves. So what I'm saying is, we introduce a geometry shader pass where we take the point from the tessellation and generates triangles based on that. And if we do that, we can 100% flip the quads ourselves because we have full control. But I don't know. 2015 legacy topics. Yeah. This one only covers triangles, if I remember correctly. We can double check. New card, no, new quad. That's just for the quad. Triangles, 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 triangles. Because what I worry is we could probably flip quads right now, but if we have this one again and we tessellate it like this, we will only be able to flip the quads for all of these, I think. So we wouldn't be able to do something like this, which is what I want to do. But if we flip one of these, we flip the tessellation for the full quad. What if we do HLSL? GameDev.net. I wonder if I wonder if there exists output topology triangle. It's it's this one we want to flip pretty much. I don't think we can change this one, can we? Like, I'm thinking that we can do some magic here. Then again, I think this would still hold true. Mm. Bruce, what if you do the opposite? Instead of dividing 2 times 2 more and more, you take the best possible odd mesh. Just subtract even number. Not entirely sure I follow, but yeah, so right now we're doing, let's do quad, and then we subdivide it more and more and more. You're saying we should do the opposite, you take... Like steps in for loop, you have I equals 0, I less than 99. Trying to wrap my head around what you're describing. Sure, I entirely understand. Blender. I'm starting to lean towards having to do the triangulation ourselves in the shader, or with a geometry shader. Because I'm pretty damn sure we could do quad flipping if we do. Because what we're getting to the geometry... Fuck yeah, we could. Oof, this would be beautiful. What we get for the geometry then is... we get quad domain shader output input 4, and we do in out triangle stream. Although I wonder, yeah, oof, this would be beautiful. If we do it like this, we have full control of what triangles we output. We could go pretty crazy here, I think. And then we output them as a triangle stream, but I wonder how much more. Oh, this would be beautiful. But. Mm. This is so fucking cool, I think. So right now we do tessellation, but between our domain shader and fragment shader, we just let Unity or whatever is in control of the render pipeline do its job. We don't care too much about it. But if we want to do quad flipping, we need to take control over it, and we do it in the geometry shader. So I'm like 99% sure that we can do the quad flipping here, and if we can do the quad flipping, we have better control over if a vertex should spawn. Ooh, that is true. One sec. So if we have this quad and we subdivide it once, the information we get down to our geometry shader is then each quad and its vertices. So we get this quad, this quad, this quad, and this quad. And then we have total control if we want to split this quad like this, or if we want to split this quad like this, because we output the triangles. We output the triangles. Although I wonder if it's possible to do We take the inputs as quads, but we output them as triangles. It should be okay. Because then we get this, 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 and this point. If we were to triangulate this one as this, and this one as this, would we get any problems? No, one sec. We just have to make sure that whatever we decide to do with this one, overdose, what's up, what's up? Whatever we do with this one, that we do the same for all of these. Yeah. Wow, one sec. Oh my god. Oh my god, I think I have it, and this would clean up so much. Oh, can we do it like this? Ooh. What if we always let, or we split the tessellation, so to speak. So we let the tessellation stages do as many tessellation as they want or as they need, but then we always leave the last tessellation stage to the geometry shader. So in this case, the geometry shader would get this quad, basically. The tessellation shader, or the domain shader, has already offsetted these one in the correct way. What we do then in the geometry shader is that we generate this one, this one, this one, this one, and this one, and build up this quad entirely as we want. But so then when we do the vertices gradually changing based on distance from camera, we do that in the geometry shader, because then we know that it's only the vertices in the geometry shader that we want to animate the offset of. And since we build the triangles, we have full control over if this one should be based on this one and this one, rather if this one should be based on this one and this one, or this one and this one. So the tessellation takes this one and tessellates it into these 4 quads. These 4 quads are then sent into a geometry shader, and each quad is tessellated once more, but in the geometry shader. We have to be extremely careful, however, but it should be okay. So these 2 quads, I wonder how unoptimized this is, but I want to try it. So here we will eventually generate, we will generate 2 versions of this vertex, one for this quad and one for this quad. Since we're reading the underlying data, we will never get different height values here. This could work. This could work beautifully. I'm a little bit afraid of the geometry shader though, when it comes to performance. Then we always know exactly how many vertices Yeah, I think this approach could do it. Oh, we wouldn't, like, this would simplify the tessellation shader so much. Like, seriously. It would be extremely simplified. Instead of worrying too much about distance to camera and which one is where and how they age and doing all of those calculations in the tessellation shader, we would just move it to the geometry shader. The new vertices would always be generated in the, like the newest vertices would always be generated in the geometry shader. Because then when we get close enough so the tessellation shader generates these quads, what we send down to the geometry shader then And or what the geometry shader then generates are these quads. I think this is it. And we pretty much, I'm optimistic, very optimistic. If this works, we solve one new problem, or we solve the quad flipping, and we also streamline the popping solution we have, and we also fix the edge cases of the current popping solution we have. So this is great. I think we're going to dive into this one. Shouldn't be too hard, but I'm wondering. Yeah, I'm going to run and fix one cup of coffee, and then we will try and implement this solution. So I just need to run AFK real quick. Let me just do this. And then we can do this. And then we can write it like this. So be right back real quick. Okay, back. Sorry about that. Let's remove this one and let's dive into adding a geometry shader to our snow shader. And this geometry pass, or what I want to, I don't know what I want to refer to it as, is going to do the heavy lifting. But I think this is the correct way to go. I do. Okay, let's see here. But we're gonna leave. Oh, fuck, it's gonna be beautiful, I think. I don't want to start destroying terrain procedural snow, so actually, let's rename this one to, let's duplicate it. And then we name this one to snow with fuck, what am I doing? Let's do this. Let's delete this one. Let me just commit this solution. I'm a little bit, we have a lot of shit. Some experiment stuff I want to get rid of here. Do we use this one, this one, this one, X compare. Direction, we're gonna get rid of this. We're gonna get rid of this. And that is about it. Yo, what's up, Vintrix? How's it going? It's going pretty good, I would say. We have this new approach, which I do believe in a lot. We're gonna, so for the past days, we have been doing, we have added tessellation to our snow shader. And right about now, we're gonna take the step and add a geometry shader as well. And the geometry shader is gonna go, it's gonna do the most important work. Okay, fuck it. Let's commit this one. And let's add a geometry shader. I think there's probably... how about you, Ventrix, by the way? How are you doing? I think we're probably gonna... We might run into a few roadblocks with this. Hopefully nothing we can't solve, but we're gonna have to find out. If we want to do proper quad flips, we're probably gonna have to do it in the geometry shader. I want to commit materials, environment, procedural, snow material, and I want to commit assets, shaders, environment shaders, terrain, procedural, snow, those two. And I'm just going to add it as we have here add tessellation. Okay, so we're gonna set this one add add partial tessellation popping fix. What issue? 131. There we go. Okay. Vintrix learning Unity, and it's pretty cool. You know me, I love Unity. Vintrix, refresh my memory. Are you coming from Godot or something else, or is it the first game engine? Okay, so what we're gonna do here, it's a little bit of a mess, but we're gonna do this. Geometry shader. And so what I want to do first is I just want to implement exactly what we have right now, but we're going to strip some things out and just see so that it works with the geometry shader, right? So we're going to remove the popping fix we have, the partial popping fix, because we're going to clean that up a lot. But other than that, I want it to look exactly like it did. So it's basically going to come down to, we're going to have the full pipeline from vertex to fragment with tessellation based on distance from camera. The only thing we're going to do is we're going to let the geometry shader do a few things here. The only thing we're going to do is we're going to let the geometry shader take whatever the tessellation shader outputs, or the domain shader, I mean, and just send it onwards to the fragment shader. So we will take one step back now, but hopefully that will make us be able to take, I don't know, 100 steps forward. We'll see. Vintrix, yeah, I'm coming from Godot, and I need to say Godot is really cool. Yeah, that's my understanding as well. But I just like Unity because it has more features. Yeah, that is basically the main reason I'm still working with Unity. I was looking for alternatives during the drama, but the features, as you say. Okay, geometry shader. Let's just copy this one. No. This one. I want to copy the input here. Take this one, and we put this here. Do it like that. We need to double check such that we have for tessellation we need required geometry. And let's see, we also need this one. Let's put it here. Anything else? Anything else? Not up here, but we do need geometry shader output. So let's see here. Geometry shader output, and I think we're gonna do it like this for now. Position CS, position VS. Actually, I think we're just gonna do this. Bam. Bam. They're gonna be identical initially, because our geometry shader is only going to take the information we get from the domain shader and output it to the fragment shader. Vintrux, yeah, but didn't they raise the drama with Unit 6? They backtracked on the worst stuff. Which I guess gave some confidence back to the community, but maybe not all. I'm still a little bit wary. Okay, I don't think we need to change anything in the current implementations. Or we do. One sec. Geometry shader output. That's our new input to the fragment shader. Max vertex count. What we're gonna do here is we are gonna set this one to 4. Because we're gonna get sent, we need to double check this, but hopefully we're gonna get sent quads. And we just want to return those quads. So we get 4 points as input and we output 4 points. So let's see, geometry shader HLSL. I hope we have let me get fuck. This is the roadblock I was the most worried about. Lines, triangles, or points. Don't we have quads? Honestly, we could probably work around this, but I want to see. I'll shader, domain shader. A geometry shader that expects primitives with 8, say for example 6 words. Okay. I mean, line adjacency, but we can't rely on I mean, we could. Honestly, I don't think this is. It's a roadblock, but I think we can get over it. I think we can just rely on doing triangles. Let's see, how would that look? But then it would be. I wonder if the. So, back to the drawing board real quick. I'm pretty sure we can solve this. If we have this quad, then we tessellate it using the tessellation shaders. So we get this. We rely on the tessellation's triangulation as well. So we get this. Maybe. Or actually, we would probably be getting more something like this. We can't rely on adjacency. But what we want to do, we want to do the last... We want to do the last subdivision ourselves. So if we get a triangle and we put a new point halfway between this, a new point halfway here, and a new point halfway here, which would leave us with these, which we have control over. But this quad we can flip. How the fuck would we flip this quad? We can probably flip this one as well, but we would have to add an additional point. One sec. Yeah, we can flip these two as well. But then we have to return additional points. That's okay. So given a triangle, we return 1, 2, 3, 4, 5, 6, between 6 and 7, 8 vertices. So we could either return a strip that looks like this, or I'm a little bit scared over flipping these, but maybe. I like the fact that we're getting more triangles. But would returning points be better? So if we return points, and then we build the quads ourselves. Oh, but dang it. It's doable. Yo, what's up, PG King? This one at 0.25. You can, oh god, that looks mathematically complicated. I agree. I agree. It would be way less complicated if we could work with quads in the geometry shader. One sec. One sec. This destroys the whole thing. Fuck. Maybe not. Maybe not. Now I'm beginning to think that the best option might be to do it by points. So for instance, if we would be getting this point, and this point, and this point, and this point, and then we subdivide it once more in the geometry shader. So for this one we add a point here, and we create this quad ourselves, this quad ourselves, this quad ourselves, and this quad ourselves. in the geometry shader. Then we have full control. But we're gonna have to read this value and this value and this value, and for each point we're gonna have to read so many things. Triangle is probably best. But I'm extremely worried about this quad flip we need to do here. Because then we need this information. I know they had one sec. Hmm. What bothers me is to create this quad right here. We also need this information, but this is not any information we get. This is not any information we get from the... It's not passed down. The only information we have is this, this, and this vertex. But we might want to flip this one like this. It's basically about finding the biggest gradient. So this would pretty much be about recreating 1, 2, 3, 4, or actually recreating 1, 2, 3, 4, 5 points. We're recreating 2 more than we actually want to output. So that means when we do the iteration for this triangle as well, then we're going to create this. What it comes down to is the 1, 2, 3, 4, 5 points we create per triangle. We create them 2 times. But maybe that's not too bad, actually. Possibly. Or let's see. Maybe. Like, it's 100% doable. But I wonder what the performance cost for it would be. We could also... What happens if we only choose to generate one extra vertex per strip? Is that what we want to do? Let's go with this, 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 and this. We send down each of these triangles to the geometry shader. So one geometry shader gets this information. And what if we only generate this one? If we were to flip it, we return 2 like this. This one still has its original position. This one has its original, this one as well. So it's not as much about, but that feels extremely bad as well. It's not as much as about splitting or flipping the quads. It's more about making them into 4 triangles like this by always having a new point here. But if we were to tessellate this once more, what would happen? The newly generated points here, we would not care about those. Generating this, generating this, generating this. So our geometry shader splits one triangle into 5 triangles. Should be able to do the quad flip here. If we can do the quad flip here, it would be extremely easy. Mm. Sick. Hmm. Now, point. We could get lines as well. I don't know. That would really help us. Maybe it would. But if we get lines. It's 100% this point we would need information about, and that would be if we could get. One sec. Where did we have... Tess... didn't we have any information about tessellation here? Saw it. Pretty sure I read that if the previous stage is a tessellation stage, we can't rely on adjacency. Was it here? Because if we get the additional, then we can do quad flipping no problem. But why can't I seem to find... Ah, fuck it. You know what? I'm still a bit optimistic about this introducing the geometry shader. But I have to run now. I will try and get some research done until tomorrow, and hopefully we can continue with this. It's the focus is going to be on adding control over how a quad is triangularized, because we always want it to be triangularized towards the biggest slope, pretty much, to get a little bit of a smoother. And if we can get that in place, then we can also implement the fade. So instead of popping, we have fading. But that's gonna have to wait until tomorrow because I gotta run. I think it was pretty good progress today. Thank you for watching, appreciate it. and hopefully I will see you tomorrow. Have a great rest of the day. Peace.